Deep within the Earth, radioactive processes create a lot of heat. And this heat can travel outwards through the movement of molten rock and right near the surface, near the crust of the Earth. It can come in contact with water, and that can force the hot water and steam towards the surface. In places where the crust of the Earth is very thin, such as in Iceland, we get these amazing geysers of steam which are let loose from time to time, and hot springs of water. We can use this geothermal energy to drive turbines that are connected to generators to produce electricity. So let's take a look at the flashcard. In some volcanic areas, hot water and steam rise to the surface. So the steam can be tapped and used to drive turbines, which are coupled to generators, which produce electricity. And this whole process is known as geothermal energy. It's not just in places where water and steam rise naturally that we can build a geothermal energy plant. We can actually build a geothermal energy plant in a suitable location where the crust of the Earth is thin enough, and we can inject water down many kilometers so that it is heated up by the molten rock and steam is produced, which is then forced back up a pipe. That steam turns turbines, which generates electricity. The steam condenses back to water and gets pumped back down into the molten or the very, very hot conditions once again. And this is happening, for example, in Kenya, in the Rift Valley, where there are ideal conditions for geothermal energy because the crust of the Earth is thin enough to drill down and be able to have it hot enough within that distance to make water turn into steam. So that's geothermal energy. And yes, the disadvantage is that you can only have a geothermal energy plant in specific locations where the Earth's crust is thin enough, but the actual power plant itself is relatively clean and doesn't produce polluting gases, greenhouse gases, and such like.